I've got a right triangle, and this is a 45-degree angle. And since all the angles inside of a triangle have to add up to 180, this must also be 45 degrees. Since these two angles match each other, they're congruent, it means the sides are congruent. You can call this a right isosceles triangle, but for what we're doing today, we're going to call it by its other name, the 45, 45, 90 special right triangle. Now, this thing has ratios on the sides. I'll pop them in right here. Today, we're just going to use that information to find missing sides. So what I've got is two sides that are congruent. So if this is 5, this is also 5. And using those ratios for the 45, 45, 90 triangle, we know that this is that side times the square root of 2. That was the easy version. This is the one that's a little more difficult. It's when they don't tell you what the sides are and they give you the hypotenuse. Well, I do know if this is x, this isn't really y, this is also an x. And then this is supposed to equal x times the square root of 2. So I can make a little equation here and solve. So I have x times the square root of 2 equals 5. So I'm going to divide both sides by the square root of 2. And then you get something that you think is a wonderful answer. And if you were using a calculator, you would plug that into the calculator. But if you're doing this for a grade or for a standardized test or something, I'm going to need you to rationalize the denominator, which means you are going to take the top and the bottom times that radical. And when you multiply 5 times the square root of 2, we write it like this. The square root of 2 times the square root of 2 is 2, but it really starts out as the square root of 4. And then you get 5 square root of 2 over 2. This is your x. So this side is 5 square root of 2 over 2, and so is this one. 5 square root of 2 over 2. All I did was move the 5 from a side to a hypotenuse, and the problem just kicked up in difficulty.